So welcome to the post-class video on strong acids and bases and weak acids and bases. And I just wanted to do one of the problems, or a problem like the ones that were at the end of the activity, because we didn't really have enough time to get into that in detail.
Right.
And so this is very like one of them. What is the pH of a 0.3 molar lactic acid solution? And I've written up the Ka of the lactic acid is 1.4 times 10 to the minus 4. And this is something that I just looked up in the table of Ka values.
Right, and Ka, remember, is our equilibrium constant for an acid.
Right, for an acid dissociation. That's why there's that little A down there. And so I've written up the formula for lactic acid, C3H5O3H. And this H is different. That's the acidic proton.
Right.
And it's in an equilibrium with its conjugate base, and then H+. Okay, so how are we going to set up this problem, Tyler?
Well, let's start by getting an equilibrium quotient.
Okay, so we can write up our equilibrium expression.
That's the word I was looking for.
Ka equals, voila. And so what do we know? We're trying to find out the pH.
What do we know? We know K.
We know K. That's good. What else do we know?
We also know the concentration of lactic acid.
Yeah. And so probably the way I would do this is I would start to set up an ice table, right? And this is the concentration of lactic acid. Is that the equilibrium one or the initial one?
That looks like it's the initial.
Yeah.
Like they're putting in, they know that they put in 3 molar lactic acid. They don't know how much of it's still lactic acid. They don't know how much of it has ionized.
Yeah. So we assume when we put that in, what are our initial amounts of these two things?
Will they be 0?
0. Right? We're pretending that no reaction actually happened.
Right.
And then we can say, okay, that's my I. My change, well, this is going to increase or decrease?
Well, it's probably going to decrease.
Yeah.
Now that we know the Chatelier's principle.
So minus x
Right.
plus x plus x.
Right, and there's no coefficients, so we don't have to worry about those.
Yep. And then here I get 0.3 minus x. Over here I get x and x.
There we go.
Right? And that's my equilibrium. And so now I can plug these into my expression with the Ka. I still don't know about this pH thing. I'm not quite there yet, maybe. But I have all the information from the problem now.
Right, and you're down to one variable, so you can solve for x.
Right. And I can already see I'm going to get an x squared, and I have an x down there. And I don't like doing the quadratic formula, so I'm going to cross my fingers and hope I can make an assumption. I can make an assumption that x is going to be small. And this K value is pretty small, right? So that's probably a decent assumption, but I'm going to check it at the end to make sure. So I'm going to assume that the x that's part of the difference approximately goes to 0. It's going to be really small.
Sure, so what we have is x squared over 0.3.
Yep. And I cross multiply, solve for x, and
Okay, so now we have our value for x.
Great. And what does x tell us? Well, x is the final concentration of H+.
Right, and that's how we get pH. So basically we know the concentration of H+ is 6.5 times 10 to the negative 3 molar.
And then to get pH, I just take negative log of that, right? Equals 2.19.
Ah.
Now, if I was paying attention to significant figures, I would say, well, I have 2 significant figures there. I only have 1 there.
1.
Yeah, I probably should have said 0.30, but let's pretend let's say we only had 1.
Okay.
So I want 1 significant figure down here. And this is one of those weird things about logs and scientific notation and significant figures, is that the number out front doesn't count for logs.
Ah.
And that's because this represents the power of 10. Anything on this side of the decimal doesn't count. And so rounding this off to 1 significant figure, you actually get 2.2 2.
Right, and that's only for logs.
Right, that's only for logs.
The rest of the time, please don't forget to count that digit.
Exactly, exactly. Okay, and so this is basically just another equilibrium problem, and you're
Right.
getting pretty good at doing these now. Okay?
All right.
So I hope this helps, and see you in class.